Have you tried drawing a picture for this?
Not yet. Yes.
All right. So the picture is important, like just like in the other problems. Person's running this direction to the right, and they come down and they go splash right in the water. Are you with me?
Yes. All
Okay.
right.
Great. So the picture here, the picture is really important because it's a different picture than before. Like before, it was starting at ground level, went up, and now it's a little bit higher, starting higher up, and then hitting the water. Is that reasonable here?
That is correct.
Okay,
Yes.
so we want the speed. Speed is another word for velocity, but it's slightly different. Speed is always equal to the absolute value of velocity, because he's actually going down when he hits the water. So the emphasis here is on finding the velocity. So we need to know the time. Surprising. We need to know the time when he hits the water. Which equation do we use for time?
The vertical.
Yep, y equals y
solution.
naught plus the initial velocity with respect to y plus 1/2 the acceleration in the y direction t squared. Now, this is a different problem. You tend to want to choose your origin to be right where I've drawn these crosshairs. This is your origin, which means that the initial height, y0, is 10 this time, because he's starting 10 meters up.
Oh yeah. Okay.
Is that okay? Because it's a critical part of this. So he's starting 10 meters from like, you're used to the ball. You're used to problems where, okay, I kick the ball from the ground level and hits the ground later on. Here it's starting 10 and landing there. It says a diver runs horizontally. That means that he's only running to the right.
Yes.
So when he jumps off, he has no velocity or speed downward. Like the instant right before he jumps off, he's only running straight. He's not, in no way is he running down. So the initial, what this means is that the initial velocity in the y direction is 0 if he's only running horizontally.
Oh,
But the
okay.
initial velocity in the x direction is 1.2.
Makes sense.
Okay, so that means that this term right here is 0. What is the acceleration in the y direction?
In the y direction, it is the 10. Oh, wait, no, 1.2 meters per second.
It's
We put
minus
that in there?
9.8 meters per second squared.
Oh,
The acceleration in the y direction is almost always gravity, g.
I see.
So it's minus 1/2 9.8 t squared. So we get an equation here, y equals 10 minus 4.9 t squared when you reduce that. What is the value of y when you hit the ground? The water in this case.
Is 0, right?
0. So we can set y equal to 0. And you can calculate t. You can solve for t here. So when you solve for t, you get t equals the square root of, let's see, 10 over 4.9.
All right. I'll calculate that. I got 1.43 for this.
Okay. And again, like, this is not what the question asked for. The question didn't say, hey, what's the time? How much time to hit the water?
It's looking for the speed, right?
It's looking for the speed. But like I've said many times, it's like repeating myself, like, it's good to remember this. You got to find time, okay? Because you almost always use it. Now, do we need to know how far out it went? Does it ask for that?
No, it does not.
It's not. It asks for the velocity. So the other night, and I think it's in this thing here that you sent me, there is there's an equation for for velocity. Velocity in either direction is equal to the initial velocity plus the acceleration times time. But there's really two equations. There's the x direction and the y direction. Is there acceleration in the x direction?
No, right?
It's zero. So the velocity in the x direction is always the initial velocity in the x direction. But in the y direction, there is acceleration. It's gravity. It's minus 9.8. So in the y direction, the velocity is the initial velocity in the y direction minus gt, or sometimes it's written as v0y minus 9.8t. Your equation sheet goes plus gt, and then it says
Yeah.
g is minus 9.8. So what I'm saying is consistent with that, but you kind of have to make this commitment early on. Like, do you want to write it as plus gt and then g is negative 9.8, or is it you just okay, g is 9.8, so I'm going to write it as minus gt minus 9.8t. You have to decide that. I'm just trying to give you the information here. This is kind of the way
Okay.
we're going to go here. So when you hit the water, there's a lot that goes into this. When you hit the water, you're actually still moving both forward and down. Like you've got some right and some down. Maybe you saw that in class today.
Yes.
So the right part is the easy part. That's the initial velocity in the x direction. Your initial velocity in the x direction is 1.2.
Okay.
Your velocity in the y direction, well, the initial velocity in the y direction was zero because it was just the person was just running straight, minus 9.8 times the time that it took to hit the water, 1.43. So
So nine
initial
point
velocity
eight.
y is zero, time is 1.43, g is minus 9.8.
Mm-hmm. So VY, I calculated it'll be 14.01.
It's negative, right? Negative 14.
Yeah, negative.
Okay. So what this means is in the y direction it's going down minus 14, and in the x direction it's going over 1.2. And your
Mhm.
instructor gave you an equation here. Actually, your instructor did not give you an equation. Um, the speed just before striking the water is the hypotenuse of this triangle. Like, imagine I slide this 1.2 down here. There's a hypotenuse of a right triangle. You're finding that.
Oh,
So the velocity is the square root of the x velocity squared plus the y velocity squared, square rooted. So you've got two values here. You've got 1.2 and minus 14.01. Your
can I plug them in?
Yeah, it's going to be 1.2 squared plus minus 14.01 squared, square rooted.
And the square root of this should be 14.06.
Okay, so it's about 14.06 meters per second.
True.
I think it's possible the instructor didn't mean for you to go down this extra set of steps, but I'm not sure, because this isn't my problem, so I can't tell you for sure. Can we move on to number two?
Yes, we sure can.
Okay. Okay, so it says an airplane is moving horizontally with a constant velocity of 115 meters per second at an altitude of 1,050 meters. So the airplane is up here. This is your airplane. The ground level is down here,
Mhm.
and this height is 1,050. It's moving only horizontally at 115 meters per second. And a care package that falls to the ground does this. It goes release and comes down. kind of like the last problem where you hit the water. Now, one of the things that I think it's unclear, and as a driver, this applies to you. When you're in your car, and your car is traveling down the road at, let's say, 40 miles per hour, how fast are you traveling?
Okay, so if the car,
You are also traveling at 40 miles per hour. Now, why don't you
oh,
feel like you're moving? And that's the next logical question. It's because relative to the car, you feel like you're not moving because the difference between them is zero.
oh,
So when you're in an airplane, I know you've been on an airplane because I know you went to, I think, Maryland last year. Um, you were in an airplane going like 400 miles per hour. Well, you were going that fast, whether you felt it or not. You were inside a plane going that fast. You were moving that fast. And you may be thinking now, why is he bringing that up? Well, this care package inside the plane is always traveling at 115 meters per second. So when it's let go, it's moving at 115 meters per second. That's the assumption that you have to make to do this problem.
oh, okay.
And it's reasonable. Like it says an airplane, you don't really care. It's the fact that this package is moving at 115 meters per second. We have to determine the time required for the package to hit the ground. Okay, which equation do we use for time?
The horizontal velocity, right? I mean,
We
just horizontal.
Nope, nothing to do
The
with
why not?
horizontal. The vertical.
I mean,
Y,
vertical. Never
yeah,
mind.
y
The why
equals
not?
y naught plus v naught in the direction of y times time plus 1/2 the acceleration in the y direction times time squared. If you choose your axes down here, which is very common to do, your y0 is 1050. When it hits the
Okay.
ground, what is the y value when it hits the ground?
The y value when it hits the ground, it should be 0.
0. We just talked at length, and I've drawn it correctly where the velocity is only going to the right. Does it have a velocity in the y direction?
Does it have a velocity in the y direction?
Yeah, it says that it's only moving horizontally. So that means the initial velocity in the y direction is 0.
Okay. So velocity, we can just take that out, and we can just
Take
do
that all
plus
together. What is the acceleration in the y direction?
negative 9.8, right?
Yes.
And then multiply that by t squared.
Yep, so you get 0 equals 1050 minus 4.9 t squared. So go ahead and solve this with t. I'll be right back.
Sounds good.
Hey, Jack, just checking.
Yeah, I got 14.64.
So time is the square root of 1050 over 4.9, and you said 14.64?
Seconds, yes.
Yeah. Great. Okay. We're totally done. I mean, that's all it asks for.
Perfect.
So I'm not sure why time wasn't given, why this question wasn't given first, but that's the way it was. Should we move on to 3?
Yeah.
Okay, so 3 is not a physics question. It's a trigonometry, maybe even a geometry question. If you recall, I said, hey, did you do a math review in this class? And I think you said no. And well, this is your math review. This is like, hey, students, we need to go through this stuff to make sure you know how to do the problems. You already know how to do these problems because you've already taken geometry. We've already done a little bit of this. So we're talking about sine, cosine, and tangent.
Yeah.
So to find angle y, we're also using the Pythagorean theorem. So y is like one of the legs. So we can say, and I'll write that out here, a squared plus b squared equals c squared.
Y
To
should
find,
be square root of 44.
yes. And this is actually different than your math class. You can just throw that in your calculator and get a number. They fully expect that. I know it's 2
Oh,
squared
so this,
11, but they actually want you to get a numerical value out.
all right, 6.63.
Great. Now, to find the angle, you can use any of the trig functions, sine, cosine, or tangent, since you know all three sides. Let's review those. Sine is opposite over hypotenuse.
Mhm.
Cosine is adjacent. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. Relative to this angle right here, this is the adjacent, and this is the hypotenuse.
So cosine for this
Yes,
case.
so we can say cosine of theta, that's the angle, equals 10 divided by 12. To solve
That's just
this,
0.833 or whatever.
well, to solve this, you have to undo cosine. So do you remember how to do that?
Is it the negative cosine? Yeah, cosine of 1.
It's arc cosine, cosine inverse, and if you have your calculator handy, make sure it's in degrees, and let me know what value you get for that angle.
It's just straight up 1. Because it's like
Uh,
0.9999894 or whatever.
so the angle is
Oh wait, never
probably,
mind.
make
Did
sure
that
you're in
incorrectly.
degrees. Yeah, it's
All
I'm
right,
checking.
33.5.
Yes, that sounds more reasonable. Um, yeah, 33.6. Okay. All right, let's move back to your questions here. We're just going to keep going through this. Is that okay, or is there an order that you want? If there is, let me know.
Um, there was this one that I didn't understand. Number 7, I didn't understand how to do these.
Okay. We go to a different page. 7. An object is thrown up at an angle. Is that which one? Is that 7?
Yes.
Okay. Find the minimum speed. Okay, during the motion. All right. All right. Okay. This one right here, the one I've got thrown up here.
Perfect.
Okay. It shouldn't say thrown up. It should say thrown at an angle of, because when you think up, you think straight up. So what
Mhm.
the instructor's saying is it's an angle of 30 degrees with the horizontal, and it's got an initial speed of 19, and then it comes and hits down over here. Is that drawing kind of consistent with the way you see it?
That's reasonable, yes.
All right, so it says find the maximum height of the object and the maximum horizontal distance. To find the horizontal distance, you need time, just like most every problem we've done so far.
Try to
Which
calculate that out. Why
Yep.
not?
Yep.
And then plus Vy plus 1/2 Ayt
Squared.
is
So which of these quantities is zero?
for 0.
Which
0 would be y initial. Why not? All right, so
and
y
it
equals
hits the ground back
0
over at zero. So this one's also zero.
plus 19 plus 1/2. Oh wait,
So
no, I'm forgetting this.
the initial velocity, you have to draw the triangle and find the y component.
It'll be 19 sine of 30 times t. Is that how that goes for the
Yes. Yes, exactly.
or is it t squared? Oh, never mind. No, t squared is at the end. All right, and then plus 1/2, and then acceleration, which would be negative 9.8 t squared, and I can calculate that out. I could get like t equals 19 sine of 30 over 4.9. And I can calculate that out. 19 sine 30 divided by 4.9.
Perfect. Excellent.
Oh wait, I did that. Put that in incorrectly. There we go. 30. Now I get that divided by 4.9. That should be 1.93 or 94.
Okay, great. Again, though, that's not the answer, but it leads us to the answer.
Yes.
You can use the x equation, the x naught plus the initial velocity in the x direction times time plus 1/2 the acceleration in the x direction times time squared to find the horizontal distance.
All right. And x initial is 0 plus v0 xt, which would be 19 cosine of 30 degrees times t plus
And the acceleration, yep, go ahead.
And it's just by itself because there's no acceleration in the x direction.
Okay.
But what about the x? Do I set the x equal to 0 because it's on a flat plane?
Well, you're solving for x because your x is how far it went.
Oh, never mind. So 19 cosine 30. I multiply that by 1.94, which we just got, and it should be 31.92 meters.
So we'll say about 32 meters. So that gets us down to A or B.
So that gets us down to just A and B are now tied, and now we gotta.
So where does the maximum height occur when we go back to our picture?
Maximum height occurs at 1.94 divided by 2.
Right down the middle,
Yeah, which would be 0.97 seconds.
So we know at 0.9. Do we have an equation for the y height or the y, how far it went in height? We do. It's actually this one here.
We do have how far it went, yeah.
It's this one right here. It's we were solving for when it hits the ground, but more generally it's y equals 19 sine 30 t minus 4.9 t squared. And the only variable there is t, but t equals 0.97 in. And get the value.
There we go. So by equals 19 sine 30 times 0.97 plus 1/2 negative 9.8. That should be 1.94 squared.
What did you come up with for that?
Times 4 point. It's weird. I got 9.215 minus 18, which would be negative 9.22664.
Okay, so I'm gonna calculate here. It's 19 sine 30, and you said time is 1.94, but you cut that in half, so 0.97 minus 4.9 times 0.97 squared. I get 4.6 for that.
Wait, so let me see if I did something wrong here. 0.97. 0.97 squared is 0.94 times 4.9. Oh, never mind. I did that wrong. Perfect. So we get A for this, right?
Yeah.
Sounds good.
I want to point out now that part 3 you already have the answer to. Part 3 is D.
Perfect.
Okay. Part 2 is kind of a there's a I don't have a good resource for this, but I'm going to try and do my best to draw part 2 here. When you when the person when the ball is thrown in the air, let me draw the trajectory here. So it goes, something goes up and goes down. I think we talked about this yesterday. When it reaches this top point, it only has a horizontal component of velocity. Do you remember that? We talked about that. Like when you throw something up, even if you throw it out away from you, but throwing it up is the better example. You throw something straight up, there's an instant in time where it's neither going up nor down. It's just stagnant.
Yeah, it
Okay?
stops basically.
That's kind of what's happening at this apex point. It's neither going up nor down, but it's still going to the right. The thing is, though, is the velocity to the right is always the same. It doesn't matter where you are. Like, it's always the same arrow size. But when you are initially, it's got some arrow that's going up. Like we draw that triangle. Is that okay? Like we draw this triangle and we say, okay, there's a little part to the right and there's a little part up.
Yeah, I remember
Okay.
that.
Now acceleration is working against this up arrow. So here it's a little bit smaller. Here it's a little bit smaller. Here it's a little bit smaller, a little bit smaller, and then it becomes 0. But then it comes back down and it's a little bit bigger, gets a little bit bigger, gets a little bit bigger, but it's going the other direction. So what I'm asking you to look at, like the ones going to the right are always the same size the way I've drawn them. The ones going up are getting smaller because gravity is working against it. Then they get bigger going down because gravity is helping it.
Yeah, I see.
So when you throw something up straight up into the air, the ball starts slowing down, comes to a stop, and then comes down going faster and faster and faster.
Mm-hmm.
So the minimum speed occurs here at the apex.
Oh, that's what that is? Okay.
Okay, at that top point, it's just the 19 cosine 30.
Oh, so I just put 19 cosine 30. Is that the whole problem?
Yeah, but there's a lot that builds up into that, and that's why I drew the picture to really try to like express why it's that. I mean, I could just give you the answers to these in about 10 minutes, and that doesn't help you much. But
Yeah, not really.
We gotta. Did you calculate 19 cosine 30?
Yeah, I guess it's 16.45.
Okay, so that is the correct answer according to the way this problem is written. There is another answer that could be correct, which is D, but that would only be if it was asking about in the y direction, which I don't think it is, but there's a lot of uncertainty in this for me because I don't know what the instructor is trying to emphasize here. Should we go back to an earlier question, 5, or where do you want to go from here?
I want to go a little bit
Or
forward. I want to go to number 9.
number 9. Okay. Number 9 here. Okay. So we're going right to a tough one here. Stone is thrown from the top of a wall upward at an angle of 30 degrees. Okay. I'm going to snip this picture in. So this, all the problems that we've been doing lead up to this one. You started out with some questions where you're at ground level and and you throw something, then you're on top of a building and you throw something out to the right. This one, you're throwing your velocity. There's a horizontal here, and you're throwing it at an angle relative to that. You're throwing it this at 30 degrees here, velocity of 20 meters per second. So that means there's an x component to the velocity and there's a y component to the velocity. Can you calculate those for me, please?
Oh, okay. So we got 20 is pretty much the hypotenuse. Then we got 30 degrees and x, then y. So then for this, it's like 20 cosine 30 for x.
That's right. And then for y?
And then it's just 20 sine of 30 for y.
Good. Excellent. Okay. Um, find the horizontal distance that it travels. Okay. To do this, we always need the time.
Yes.
Which equation gives us time?
I'll try to do this by myself and I'll give you the answer.
Okay. Yeah. Find the time and then we'll talk. And then if you want, you can throw it into the next equation.
Perfect. Vy t plus a y t squared. Okay. So 4 is the so 4 goes in for initial
because it's starting at a height of 4.
Oh, okay.
Up here, that's why I'm choosing the origin to be down here.
I see. So 20
which is a common thing to do.
So we set y to 0?
Yes.
For the left part? How can we set y to 0 there?
If the origin is down, is where these crosshairs are, y equals 0 everywhere along this line, and that's where it hits the ground at y equals 0.
I see.
You could put the crosshairs up here where the person's throwing from, but that's not as helpful. Is not nearly as helpful as the way I just showed you.
So t ends up being negative 4 over 20 sine 30 minus 4.9 t.
So you're doing this common thing where you're in this physics class and all of a sudden you forget how to solve a quadratic equation. So what I mean by that is if I said, hey, could you solve this 10x minus 4.9 x squared, or if I wrote minus 4.9 x squared plus 10x plus 4, you would use the quadratic formula, or you would graph this to solve.
I see what you
Depending
mean
on what your instructor wants, you could do one or the other. I graph everything now because it's just faster, but for me, but I've got a computer in front of me. That's a big advantage for this. I'm going to snip in what I graphed in Desmos because you might actually find this useful when you look back at the notes. There's actually two places where it is zero. The one that you don't care about because it's not meaningful is the negative time. It's right there. And this one up here I'd have to draw in 1.02 comma 9.102. But the value you're looking for is the one down here, the 2.383 seconds.
All right, so t equals that. So once we get that time, then we're looking for overall. We're looking for the horizontal distance.
Horizontal distance, and if you start by writing that equation, you realize right away you need time to find the horizontal distance. It's the same kinematic equation as in the y direction, x naught plus v naught x t plus 1/2 the acceleration in the x direction times time squared. Based on the way we made this drawing, x0 is 0. Even though you're starting up 4 meters, it's still 0. The initial velocity in the y direction is given as, let me get back,
20, right?
20 sine 30 t. And then what is the acceleration in the x direction?
0.
0. So that goes away. So your range or your x coordinate is 20 sine 30 times this 3.83.
Or is it 2.83?
Sorry, 2.83. I was wrote that down wrong.
That's fine. We'll correct it. 2.83. 2730. Multiply that by 2.83. 28.3.
Okay, excellent.
Perfect. All right. So next I want to go back to the first page, to the other page that I sent you. It starts for number 1, it's like a ball rolls off a 1.0 meter high table and lands on the floor 3.0 meters away from the table.
Okay. Do that for sure. All right, I'm snipping it in now, and you can tell me if this is the right one.
Perfect.
Okay, the picture's critical. This one actually reasonably asks for time first because that's what you do find. You've got a ball, marble, whatever, rolling off, and I know we think it grows straight down, and I'm going to exaggerate this, but it takes sort of a path that's more out and then down. To 1.0 meter high table, it lands 3 meters away. How long is the ball in the air? Okay, which equation do we usually use for time? The y equation. So we know that y equals y naught plus v naught y t plus 1/2 acceleration in the y direction times time squared.
We don't have an angle here, so what do we do for velocity?
The assumption of this problem, and you can verify for this for yourself if you want to slide something off your table, it's only moving in the x direction. So that means the initial velocity in the y direction is 0 because it's only moving in the x direction. That means this whole thing is 0.
Oh.
We know that the initial y position is 1, and we know that ay is minus 9.8.
So it just turns into 1 minus 4.9.
Yep. And then when it hits the ground, what's the y value? Well, if it starts at 1, that's because my origin is down here at 0, 0. What is the y value when it hits down here?
The y value when it hits, 0.
0. That's what it means to hit the ground. So let me actually change it to 4.9 t squared. Sorry, hands cramping up a little bit. So t is equal to the square root of 1 over 4.9.
0.45.
Okay. And that's part A. How long is the ball in the air? Yay. Okay. With what horizontal velocity did the ball roll off the table?
0.
Well, then it didn't move off the table. Horizontal. Horizontal means to the
Oh,
right.
never mind. I thought vertical. Never mind.
Vertical velocity before the ball rolled off the table is 0. Okay. To find the horizontal velocity, we're going to use the range equation, the x equation. X equals x naught plus v naught xt plus 1/2 the acceleration in the x direction times t squared. Because you have time, you can use this equation. If you didn't have time, you definitely wouldn't use this equation.
All right, so for x, x initial 0, right?
Yep.
Plus velocity, which would be like,
We don't know that.
velocity doesn't work in that. So
We don't know the initial velocity. That's what we're trying to find.
Oh, okay.
The time we just found out is 0.45. What is the acceleration in the x direction?
0, right?
0. X is how far it went. We know it went 3 meters.
Oh.
So our equation, it started out really complicated and then it became really simple.
3 divided by 0.45 is 6.66666. So
6.67.
Yeah.
Okay, meters per second.
What is the vertical velocity of the ball?
Let's do part D next. What did remember I showed you this picture up here with the arrows going out to the right. What did I say about the size of these arrows? Do you remember? The ones going to the right.
Sorry, what was the question again?
The question is, what are the size? Looking at the size of the arrows, I made a really important comment here about the size of these arrows going out to the right.
It's even.
They're all the same because the velocity in the y direction is the same. So the velocity here, when it starts, is the same as the velocity out to the right here, out to the right here, out to the right here. Part D is really the same as part B. The horizontal velocity is always the same.
So it doesn't matter. Huh.
That's right. Well, I mean that D is the same. It's the what we just found, but C is different.
How do we? So for C, is it just 0?
No. I mean, but I want to make sure that sinks in. Like you're okay with that.
Yes, I am okay with it.
So the velocity in the y direction, I don't like the scrolling of this sort of format, but that's all I got here to show you. In that very first problem, we made a division here. The velocity in the y direction is always, it's really this equation. It's the initial velocity in the y direction minus gt. So we're going to use that down here in our problem. The velocity in the y direction is the initial velocity in the y direction minus gt, or initial velocity in the y direction minus 9.8 t. What is the initial velocity in the y direction? We looked at the figure again if we need to.
Initial velocity in the y direction.
Yeah.
It's usually 0, right?
In this case, it's 0 because it's rolling straight. So that means that this is 0. We know that G is 9.8, and we know that the time it was in the air was 0.45 seconds.
Mm-hmm. One more thing that I found, my teacher in class, he did a different way of finding the range formula. He set it up as VF equals V naught squared sine times 2 theta over G over gravity.
So the what your instructor gave you is correct, and it's a formula that works if you have all those other quantities. It doesn't work well for learning, and I think you want to learn. So what I'm showing you here is a method to always know how to get to the right answer rather than just, oh, it worked on this problem. What you'll find on a test, and this is what most students have happen to them on the test, is they're not sure which equation to use and why. And I feel like you're getting really close to knowing which equation to use and why, and knowing that, okay, we got to get time first. Usually we got to put time back into this equation to get distance or something like that. Your instructor is correct. It's just a shortcut, and it doesn't work well when you're trying to do this with the first time, but absolutely works. So this one's about minus 5-ish meters per second.
Mm-hmm.
And I think that's all it asked for. We don't have time to do a complete problem. I could probably answer or draw a picture, or I don't know, I could maybe quickly do something if you got one more you want us to look at.
Um, what about like 7?
7. A ball is thrown horizontally from the roof. That one?
Mm-hmm. Yes.
Okay. What was the ball's initial speed? All right. So I'll just go through this real quick without a lot of
Explaining.
explaining,
Yeah,
and maybe you'll have the video and the notes later on. So, okay. So we're going to use the y equation. It's always good to draw a picture. 50 meters tall, lands. It's thrown horizontally, lands 45 meters away. What was the ball's initial speed? So we need time. We know that it started out 50 meters minus 4.9 t squared, and that's 0. So t is equal to the square root of 50 over 4.9. You can find that. We know that it went 45 meters away, so x equals, that's our 45, equals our initial velocity in the x direction we don't know, but we know that it went out square root of 50 over 40 over 4.9. So v0 x times t, v0 is 45 over the square root of 50 over 4.9. All right, so that is all the time we have for today. I'm going to send the notes out to you relatively quickly, and then the recording in the same email, and you'll have access to that within probably 15 minutes.
Thank you. Appreciate your time, Matthew.
You're welcome. Good luck. Hope it works out.
Thank you so much. Have a good rest of your night.